All right, guys, so the next chapter, the next new thing we're going to be learning in Algebra 2 is rational functions. Rational functions. Well, a rational function is just a functional expression that's in a fraction form. So the very simplest rational function is going to be 1 over x. Anything in this form is going to be a rational function. Now, we could also have, say, x over x squared minus 9. This is also a rational function. Anything that has variables in the denominator, we could have them in the numerators, but in top and bottom, is going to be considered a rational function. Now, one of the key things with rational functions that we're going to have to do is we're going to have to be able to factor. Because if, page, I had x over x squared minus 9 plus 1 over x minus 3, we're going to need to combine them to be able to actually solve and do things with this function and see how it works. So we're going to need to be able to combine fractions. Well, for me to be able to add or subtract fractions, the denominators have to be the exact same. And we want them to be in simplest form. We don't want any repeated terms if we can avoid it. So in order to do that, and make sure we're doing that properly, we're going back over factoring. We've done this once before. We did this in the fall. And we're going to do it again. So this week is mainly going to be going over factoring. So hopefully, this is just going to be refreshing a few things. It's not going to be that bad. When we look at factoring, and we're going to factor this here. We're going to do most of these here. We're going to have a greatest common factor and an a value equal to 1. But the first main thing we do when we factor is we're going to look for a greatest common factor. We're going to look for a GCF, and that's what we're going to be doing with these first few problems, is finding the greatest common factor. Now we look at this here, 10x to the 7th minus 10x to the 4th plus 7x cubed. We want to see, is there a greatest common factor? Is there something in common in all three terms here? Well, we have 10, 10, and 7. Well, there's not a number in common, but there is something in common with all three. We have what? X to the 3rd, x to the 4th, and x cubed. They all have a factor of x. They all have a term of x. And more specifically, they all have x to the 3rd in common in all three terms. So we can factor that out. And when we factor that out, well, the 10's not going to change. I'm not going to have x to the 7th anymore because we're factoring 3 out. We're pulling 3 x's out of it. So how many do we have left? 4. Well, minus 10. And we're going to have x to the what? So we had 4, we factored 3 out. It's just going to be x. Plus 7. But we have x to the 3rd, and if I factor 3 out, we're just left with 7. And that's as far as this is going to go. And there's no real way to factor it down simpler than this here, because this here won't simplify any further. We can simplify it, but it's not actually getting simpler, because these two terms here do have a common factor of x, and if I factored it out, well, it would be x to the 3rd, parentheses x, parentheses, 10x cubed minus 10 plus 7. Well, that didn't make it simpler. That just added more parentheses and made it a little bit more complex. We went the other direction. So this here is as simplified as it gets. These first so many, we're just going to have a greatest common factor. And we get this here. Any questions on this here so far? Okay. Well, let's look at this one here. So again, we're still just dealing with greatest common factor. Hopefully this is easy stuff. You've done this before. Now, if I look at this here, well, we have a term with x and a term with y, yes? So that's not in common because they're different on both of them. But is there a greatest common factor between these two terms? Should be, is say 3, because 3 is a factor of negative 24 and 15. 3 goes into both of those terms. So we can factor it out. Well, negative 24 divided by 3, if we factor 3 out of negative 24, we're left with negative 8y. Plus, if I factor 3 out of 15, or 15 divided by 3, I'm left with 5x. And that's as simplified as we can get it. And the main reason we're kind of doing this here and getting these factors out is we really want the simplest form, the simplest set of factors that we can have. Because when we start dealing with these rational functions, anything we go over, whatever the simplest thing the denominator is, we have to simplify it back out. So it ends up coming back out anyway. So if we can keep the denominator as simplified as we can get it, it's going to work out better for us. It's going to make the problems that we work a lot easier. All right, let's look at this here. So when we look at these four here, these four terms, we want to look at the numbers first. So we have 49, 28, 28, and 7. So we need to see, is there a greatest common factor between these numbers? 7. Is there anything else between these four terms? Is I have a u, I have a u squared, I have a u squared, and I have a u. So I do have a u all the way across. So we can take one out. Because we're looking at these greatest common factors for the variables, we're almost looking, is there a variable in common with every term, and what's the smallest one? Because that's the most we can pull out. And we can only pull out one u. There's no v all the way across, mainly because of these two terms here. Since neither one of them have a v, we can't factor it out. Well, actually, I'll take that back. We can factor it out, it just wouldn't be nice. And I'll explain that more here in a minute. Now, if we factor 7u out of 49uv cubed, well, 49 divided by 7 would be 7. We have 1u, and if we factor it out, it simplifies out. It would just be 1. And we're left with v to the third, because we're not doing anything with it. Minus. Well, negative 28, if I factor 7 out, or I divide it by 7, I'm left with negative 4. U squared, if I factor a u out, pull 1 away. So if I had 2, I'm left with 1. And we didn't do anything to v squared, so it's just going to be v squared. So that takes care of the first two. Now the third one, we're going to have plus. Well, 28 divided by 7 would give us 4. If I pull 1u out of 2, I'm left with 1. Any questions on this so far? Now, what would the last one be? Plus what? So factor out of 7, or 7 divided by 7 would be? U factor out of u would be 1. Anytime something factors out completely, we pull every single term out, it will always reduce to either positive or negative 1, depending on what the sign is. When we're factoring out using greatest common factor, pulling something out front, we will never get 0. If it all factors out, we would get 1. And really what we're doing is we're dividing each term here by whatever the greatest common factor is, yes? So I'm going to write this in a different color. It is possible to factor out v out of these terms. It is possible, but it doesn't make it simpler. So if I factored out a v, well, this here is fine, because it'd be 7v squared. Don't write this down in red, because this isn't going to be there. You're not going to have to do this. But if I factored it out, we would be v squared. We're fine with that, yes? This has v squared, so I would just be left with v, yes? But I don't have a v with 4u, do I? But what have I been doing? I've been pretty much dividing it, yes? So what this would become is 4u over v plus 1 over v. This is the way we kind of distribute, because it's written out front, yes? And if I wanted to go back, I would multiply everything by that v term, yes? So let's see this here. Well, v times this here would give me 7v cubed, correct? v times v squared is v cubed. v times 4v squared would be 4v cubed. We good with this here? Now this here, if I multiply this by v, I would get a v right here. And what's v divided by v? Anything divided by itself is 1, yes? So these would cancel, and the same thing would be true here, and just get 1. But we don't do that because it's not making it simpler, it just made it more complex. But that's a side note, and you're not going to have to worry about that. Okay? Now let's look at the next one. And then we'll move on. We'll do this one here, and then we'll move on to the next type. What's the greatest common factor between these two here? Yes. Because we have 5 and 1, so there's not a number that we'll have as a greatest common factor. But they do both have an h in common, so we can factor it out. They are both j to the third, j cubed, so we can factor it out. And they both have k squared, so we can factor it out. So let's look at this one here. So this is our first part. Well, we didn't do anything to the 5, so we have it. H, factored out an h, so that's gone, simplified. I got j cubed, and I factored out j cubed, so it's gone. K squared, factored out k squared, well, it's gone. So after we factored out h, j cubed, k squared, we're just left with 5. So let's look at the next one. This one here, well, I have an h squared, and I factor out 1h, so I'm left with h. J cubed, factored out j cubed, well, it's gone. K squared, I factor out a k squared, well, it's gone. So that's all I'm left with. Questions on this here? You feel good with greatest common factor? Yes? Okay. Let's move on to some actual factoring, or some factoring these polynomials. Now, we did this last semester, and we worked through this here. I will write out the steps out, because I don't quite have space here, and I'm not going to write them out there on the whiteboard, but I will put them back down again, and I will post to Google Classroom. When we look at this here, our first main step whenever we're factoring is to find a greatest common factor and look to see, is there a greatest common factor? Yes, there is, it'll make it easier to factor. So when we look at these three terms here, b squared, 12b, and 20, is there a greatest common factor between all three terms? Well, there is between 12 and 20, and there's one between b squared and 12b, but there's not one across all three. Since there's not one across all three, we move to step 2. And our second step was to write 2 sets of parentheses with 3 spaces. So hopefully most of this is coming back to y'all. Because we found the greatest common factor with step 1. Step 2 is to write our 2 sets of parentheses with 3 spaces. Our third step was to find the sign. And we always check the constant term. If the constant term is positive, the signs are the same and they match the sign of the middle term. If the constant term is negative, the signs are opposite. Hopefully some of this is starting to come back. So when I look at this here, the constant term is positive. So the signs are the same, and they are going to be positive. So we'd have positive and positive. So that was step number 3. Step number 4 was to find the factors of the first and third term. Well, the factors of b squared. Well, what multiplies together to give me b squared? And b and b. And when there's only one set of factors, we'll just go on and plug them in, b and b. Now we need to find the factors of 20. We have 1 and 20, 2 and 10. 3 doesn't go into 20, but 4 and 5 does. And well, the next factor after that is 5. Well, we already have that listed. Because again, whenever we have sets of factors and we're writing them out, once they kind of come together, the left and right side kind of flip. Because if I keep going, well, I'll have the numbers on the right-hand side, so we're done. Once both of those sides kind of meet together, we know we have all the factors. Kind of way to just check. But we have these here. And we need to pick one of these to try, because again, we're going to plug it in and check. Now looking at this here, 1 and 20, 2 and 10, and 4 and 5. Which one do y'all think would work? Which one of these factors of 20 do you think is going to work for this here? 2 and 10. So we can plug it in. And again, when I'm doing these here, I just pick one of them. So we pick 2 and 10, and I just plug it in. 2 in one spot, 10 in the other. Because our last step in this is to check it. We're going to multiply back out. Let's see here. Let me get another color. Let's get this one. Now, these other set that I just did in this kind of off orange, this color here, we don't normally do these in the check. We don't multiply these out. Because, well, b times b is b squared. Well, how did I know b and b? Where did I get b and b? Well, they're the factors of what? B squared. So they should multiply together to give me b squared because they're the factors of it. Or 2 times 10 would give us 20 because what? They're the factors of 20. We don't check those. I don't check those because they will give us the first and third term because they are the factors of the first and third term. So we don't check those. We check the ones in the middle. So we do b times 10. Positive b times 10, which is 10b. 2 times b, positive 2 times positive b, is 2b. And 10 plus 2b is 12b. Is that our middle term? Well, yes. So that is it factored. And that's all we have to do for this here. Any questions on any of this here so far? We ready for the next one? That over there. Okay, let's look at this here. So I look at this here, again, our first main step whenever we look at these is to see and determine, is there a greatest common factor between all three terms? If there is, we want to factor it out. When I look at this here, well, a squared, 4a, and 32, well, there's no greatest common factor. There's no term that's in common with all three. And if there's not, we move on to step 2. And step 2 is to write 2 sets of parentheses with 3 spaces. 2 sets of parentheses with 3 spaces. So we have step number 2 done. We can move on to step number 3. The third step is to check the signs. If the constant term, or kind of the third term, is negative, the signs are opposite. Because if it's positive, the signs are the same and they match the sign of the middle term. If the constant term, the third term here, is negative, the signs are opposite. One's going to be positive, one's going to be negative. Now, you don't really, there's not a rhyme or reason which one's positive, which one's negative. We just plug it in. Because again, the last step, step number 5, is to check it. And we'll see if the signs are correct. If not, we can change it. Well, factors of the first and third term. Well, factors of a squared are just a and a. That's the only factors that we'll have. Now, the factors of 32, well, there's a few more of those. But we'd have 1 and 32. 2 and 16. 3 doesn't work. 4 and 8. 5 doesn't work, 6 doesn't work, and 7 won't work. So we have these 3 here. Now, which one of these here do we want to try? Doesn't matter which one we do, we just need to pick one. 4 and 8. 4 and 8. Now that we picked them and got everything plugged in, our last step is to check. So we'll have 8a times negative 8, which would be negative 8a. Positive 4 times a would be plus 4a. And this will give us negative 4a. Is that the middle term we wanted? No, it's close, isn't it? It's the correct number, because it is 4. We're looking for 4a. But this is negative. This one is positive. Anytime we get the correct number but wrong sign, flip the signs. We just flip the signs. Now for this one here, we could have flipped 4 and 8 and it would have given us the correct answer. But that's mainly because for A, it's just 1A and 1A. It's not going to change it. But whenever the value in front of A is changed, like 2A and 3A, and you get the correct number but wrong sign, flipping the sign is going to be easier than flipping the numbers. So here, once we flipped it, this isn't correct anymore. A times positive 8A gives positive 8A. Negative 4 times A would be minus 4A, which would give us the 4A that we wanted. So this here is the correct answer. So we just needed to flip the signs for that one there. Any questions on any of this here so far? Let's do one more of these here, then we'll do the last type that we'll look at. So when we look at this here, the first thing we need to see and find out is there a greatest common factor between all three terms? Well, no, we have x squared, negative 17x, and 72. So there's not a greatest common factor between all three terms. So we'll go with our two sets of parentheses with three spaces. Since there's no greatest common factor, we move on to step 2, which is this here. Now, step number 3 is define the signs. Since the constant term is positive, the signs are the same, and they match the sign of the middle term. Well, the middle term is negative, so both of these signs are going to be negative. The signs are going to be the same. So that finishes steps 1 through 3. Now, step number 4 is define the factors of the first and third term, the factors of x squared and 72. Well, the factors of x squared are going to be, well, x and x, because the only factors of x squared are x and x. Those are the only factors that we have. Now we need to find the factors of 72. Well, 72 has a few. We have 1 and 72. 2 and 36. 3 and 24. 4 does work. 4 times, not 26, 18. 5 doesn't work, but 6 does. 6 and 12. 7 doesn't work. 8 and 9. And that's it. Because if I kept going, well, the next factor after 8 would be, well, 9. And we already have it. So looking at all these here, which set of factors do we want to try first? 8 and 9. Why would I never try 1 and 72? Why is that one never going to work? Well, we know that the signs are both the same, yes? So the numbers, these factors, when combined, are going to go up, yes? Well, 72 is already bigger than 17. There's no way to get to it. So most of these here aren't going to work. So I'm going to try some smaller numbers, 8 and 9. And when we check this, x times negative 9 would be negative 9x. Negative 8 times x would be minus 8x. And negative 9 minus 8x would be negative 17x, what we wanted. So these here would be our factors. Now, hopefully most of this is coming back to y'all, yes? Because we did this quite a bit in the fall. And this here is going to be key to a lot of what we do with these rational equations, these rational functions. Any questions on this here? Okay. We're going to skip over to this one here. We're going to skip to this problem here. So we're skipping down to problem number 8. And this one here is a little bit different. Not a whole lot. There's one step that's changed, and the rest is going to be the same. Now, our first step, which we really haven't done on the last few problems, finding the greatest common factor because there hasn't been one, well, let's look at this one here. Is there a greatest common factor between all three terms? 2. There is one. And since there's a greatest common factor, we can factor it out. We can pull it out of all three terms. So if we factor 2 out of 2r squared, we're left with r squared. 2 factored out of 6r would be plus 3r, and 2 factored out of negative 8 would leave us with negative 4. So really the only difference between this one and the one we did previously is that there is a greatest common factor. Everything else is going to be the exact same. All the steps are going to be the same. So now that we have it here, we can do 2 sets of parentheses. Now again, this is assuming that it does factor. So we look at this here. So if it factors, we do 2 sets of parentheses. So that's step number 2. Step 3 is to find the signs. Since our constant term, the 4 is negative, the signs are opposite. Because whenever that constant term is negative, the signs are opposite. Okay. Now we need to find the factors of the first and third term. Well, the factors of r squared are going to be what? R and r. The only two things that multiply together to give me r squared are going to be r and r. Now we need to find the factors of 4. Well, the factors of 4 are 1 and 4 and 2 and 2. So looking at these here, which one do we want to try? 1 and 4 or 2 and 2? 2 and 2. And the last step is to check it. Well, r times negative 2 is going to be negative 2r. And positive 2 times positive r is going to be plus 2r. And negative 2r plus 2r is 0. So that doesn't quite work. Now we could switch the numbers around. We wouldn't change the signs, because changing the signs would take it from, well, 0 to 0. It doesn't change the sign on it. Now flipping the 2 is actually not going to change anything either for this problem, because they're both 2. Okay. And since r is only 1, we've really tried every possible combination with 2 by just doing the 1. So that means we have to try 1 and 4. Well, r times negative 4 would be negative 4r. And 1 times positive r is going to be plus r. And negative 4r plus r is going to be negative 3r. Is that what we wanted? Well, not quite. We're close, aren't we? It's just that the sign is negative instead of positive. So to fix that, we flip these signs. So instead of the 1 being positive, it's now negative, and the 4 is going to be positive. Which wouldn't be this here. So if we check this, well, 4 times positive r times 4 will be positive 4r, and negative 1 times r is going to be negative r. So 4r minus r is going to be positive 3r, which is what we wanted. So we get this here. That's it. Questions on this here? So is this one here really too much different than the one we did previously? Not too much. We just added that greatest common factor, which once we factored it out, we went back to doing exactly how we had it before. Any questions on this here with greatest common factor?
Why did we not? Oh, because these were both squared.
Yeah, it's the first one that we covered, and we can go look back at that one. Easy to use the keyboard. So when we look at this here, I can't really factor this because the factors of x to the fourth, well, we could have x squared times x squared, or we can have x times x cubed, and that works, but this middle term for these here would have to be squared. I'd have to have squared terms. And if this one was going to work, I wouldn't have just an x. I would also have to have something times x cubed, because I would need both. So this one here doesn't work because we have x to the fourth. Now, if this was x squared, there might be a chance that it would work, but there's also a chance that it wouldn't. Okay? And it doesn't mean just because we have these here, these quadratics, that it's going to factor these higher degree polynomials. It's not guaranteed that it's going to factor. And if it's a quadratic, the highest power is a 2. We can always use the square root of b squared minus 4ac, because if it's a whole number, then it does factor. If not, most likely it won't. But that's it